Alright, welcome back everybody. Today we're going to look at solving right triangles. So last time we looked at doing or learning about the trig ratios, tangent, sine, and cosine for solving right triangles. We're going to put all three of those things together to find all of the unknown sides and angles. And to do this, you can use anything that you learned so far in this unit. So the first thing I want you to do is make sure your calculator's in degree mode again. Once you get out of that menu. In order to solve a triangle, you could use any of the three trig ratios. So that could be tangent, that could be sine, or that could be cosine. Okay, so those three. The Pythagorean Theorem, now that one will only allow you to find a side. Okay, so that's for side lengths only. The last one, since all three angles are going to add up to 180, if you know two of them, you can always find the third missing one. So all of these three things are going to help us do what we need to in finding all those unknowns. Okay, when we're solving triangles, you have to show all of the following in your solution. Any ratios you're going to use, the formula that you used, any substitutions or calculations, and labeling that answer with the correct units. Since there's going to be a lot of things we have to find, keeping it organized like this is going to help someone looking at it figure out what it is that you did. So we'll do a couple of examples here. Solve triangle X, Y, Z, so that's the triangle we're looking at, and give those measures to the nearest tenth for both angles and sides. Okay, nearest tenth is what we're going to do. There really isn't a right or wrong way to approach this. You can pretty much do this any order you want. I think the first thing I'm going to do here is find out what angle X is. Just personal preference. Okay, so according to angle X, that's going to be our reference angle. Now, if I label that triangle accordingly, the side directly across from it, that's going to be our opposite side length. 6 is going to be our adjacent, and the remaining one will be our hypotenuse. Okay, so in order to find angle X, the angle becomes our unknown. So I have to pick two side lengths that we know in order to use one of those trig ratios, because again, the Pythagorean theorem won't help here. So if I know the adjacent side and the opposite side, that ratio that we can use is tangent. So the tangent of theta is opposite over adjacent. If we fill in the stuff that we know, instead of saying theta, let's call it x, since that's the one we're trying to find. So the tangent of x is equal to the opposite side length of 10 divided by the adjacent side length, which is 6. Now again, if I'm looking for an angle, I need to do the inverse of whatever this trig function is. So that's going to be inverse tangent. So we're going to write x is equal to the tangent inverse of 10 over 6. And that's what's going to go in our calculator. So second tangent, 10 divided by 6. Enter. There's our angle is what it looks like for x. So again, to the nearest tenth means 1 decimal place. So even though that's a 0, I really should be including it also. So x is 59.0. In order to find, let's go find the other angle in this triangle at this point. Since I know two of them, I know what y is, it's 90 degrees, that's a right angle. I know what x is, it's 59, we just found that. In order to find angle z, that's going to be equal to 180 degrees minus 90 minus 59. Okay, so angle z is going to be, let's just do some subtraction here. So 180 minus 90 minus 59, that'll give us 31 degrees. It does say nearest tenth, so we'll go 31.0 also. Okay, the last thing left to do is to figure out how large that hypotenuse actually is. So you've got a couple choices here. You could do Pythagorean theorem since you know the other two sides, or you could use one of those trig ratios to find it. Personally, I think the trig ratios are a little bit nicer. It's a little shorter. So let's just make that choice this time. At this point, it doesn't really matter which angle you choose. You had to find both of them. Actually, you know what? I think Pythagorean theorem would be a better choice here. The only reason why, I wasn't given an angle to start with. Okay, so if I happen to find either one of those angles incorrectly, that would lead my hypotenuse to also being incorrect. So let's actually use those two side lengths which they gave us. Okay, so those have to be correct since they were provided in the question. Let's use Pythagorean theorem here instead. So let's do a squared plus b squared is equal to c squared. If we fill in the information, let's call a 6, b10. So those are going to be my legs of this, the sides that aren't the hypotenuse. And let's make them equal to our hypotenuse squared. Okay, so 6 squared will give us 36. So you can plug this whole thing in your calculator, 6 squared plus 10 squared. In total, we have 136. So 136 is equal to our hypotenuse length squared. Now at this point, if you square root both sides, let's do the square root of 136, 11.66. So again, nearest tenth, so round that 6 up 1, so 11.7 units per centimeters. That is the length of our hypotenuse. So that would be side length x, z. Okay, so we found the two missing angles. We found the hypotenuse. Everything looks good here. So whenever you're trying to solve a triangle, they always have to give you 3 pieces of information. Now, it could be 3 sides. It can't be 3 angles, but it could be 2 sides and an angle. As long as you have 3 pieces of information here, you should be able to find the other 3 missing pieces. Okay, I'm not going to do B. I'm going to leave that one for you to try. So you could give a pause in there. You could try it out. The answer key is provided to you in that Google Classroom. Let's take a look down below. So let's pick one of these. I won't do both. Let's do A. Okay, so I've got a right triangle again. I know it's a right triangle because I've got that right angle symbol in the corner. One angle is 25, and I only have 1 side length here. So again, if you count the pieces of information, you do still have 3, 2 angles and a side. So let's go decide what it is we're going to find here first. I think it'd be easier to find that missing angle first. Since I know 2 of them, I can always find the 3rd one. So let's say that angle FDE, remember it's always going to be the letter in the middle in question. So angle D is going to be equal to that total of 180 degrees. Subtract the right angle of 90, subtract the other angle of 25. So angle FDE is going to be equal to, if I do 90 minus 25, that'll get me to my answer also. So that's 65 degrees. Okay, so you can even add it to your picture if you like. Let's get that circle out of there. So let's add this in. That's 65 right in there. Now we've got to go find some side lengths. So here's where we got to pick a reference angle. I can't use Pythagorean Theorem because I only have 1 side at this point. I would need 2 in order to do that. So let's choose our reference angle of that 25 degrees, since that's what the question gave us. We didn't have to find that. The opposite side length to it is our 5. Okay, opposite, that means adjacent is down below. Hypotenuse is, of course, the one across that right angle, this way. Okay, so at this point, it's up to you or up to us to decide which side length to find. There's no bad choice here. I could use opposite and hypotenuse, use the sine ratio. I could use opposite adjacent and use the tangent ratio. Let's go find the adjacent first then. So we're going to use the tangent of theta. That's opposite over adjacent. So the tangent of 25 degrees is going to be equal to the opposite side of 25. So that's going to be 5 centimeters. Divided by the adjacent side, which we don't know. Let's call it side length EF. Okay, so start at E, travel to F, that side length at the bottom. Now I know the angle this time, so I can't use the inverse, it won't help. This is that scenario where that tangent 25 is just a number. So you can divide it by 1 and try to figure out how to get rid of the fractions. Now the way you can do this one, take the 5, multiply it with 1, that cross multiply process, divide it by tangent 25, and that'll take you right to the side length that you need. So in your calculator, you're going to go 5 divided by tan 25. That'll be equal to your side length. Right. So if we put all that in our calculator, we do 5 divided by tangent 25, close that bracket, hit enter. There's going to be the length of our side length. So the side length E to F, I don't think it said where to round to. It did not. We were we were given something to the nearest tenth in the question, so let's round this to the nearest tenth. So we'll do 10.7 centimeters. Okay, so there's theta f. Since we know that one, we can go ahead and find the hypotenuse. So you do get a choice here to use either the Pythagorean theorem or one of those trig ratios. Now again, if I use Pythagorean theorem, I'm using something I already rounded. Let's try to avoid that. Let's use one of those trig ratios because I was given an angle in the question. I was given a side length in the question. Let's use sine ratio this time to find that hypotenuse. So if I write out my formula for sine of theta is opposite over hypotenuse. We'll use 25 as a reference angle again. The opposite to 25 is still 5, but we're going to go find the hypotenuse. Let's call it DE. Same process as before. That sine 25 is just a number, which means we can divide it by 1. And if you notice, these are the exact same format, tan 25 and sine 25. The variable, the thing I had to find, was on the bottom. So we're going to approach this one the exact same way. So when you go to type things in your calculator this time, your 5 will be on top. You're going to divide it by the sine of 25 degrees. That'll give you the length that you need it to. Okay, so let's go 5 divided by sine 25. There's how long that hypotenuse is. Now notice that that's longer than the other one that we had, so that's a good thing. If it happened to be shorter, then we'd know something was off since our hypotenuse has to be the longest side length. Okay, so that means that 11.8 centimeters is the side length DE. Okay, we've just found everything about this triangle. We now know what all 3 of the angles are. We also know what all 3 of the side lengths are. So we're done here. We found everything. All the solution has been written out perfectly. Okay, underneath again, I won't do that one for you. Take a few minutes, try that one on your own, compare them to the answer key provided to you and see how you did. That's it for solving triangles. You've got one question in there if you want extra practice from your textbook. We'll see you in the next one when we talk about doing multiple triangles. So what happens when we've got a picture that may look like this. Okay, we might have multiple triangles and things to think about. So that's what we'll talk about in the next video.